Welcome to day 4 of the summit. We now have 417 registered participants, which is awesome. Really super. If you're joining us for the first time, welcome. If you're back, great to have you here. Thank you for coming back and finishing the whole summit with us together today. By way of introduction, my name is Patrick, and I'm the founder of the Climate Robotics Network and a faculty researcher at WPI, where I get to work on climate robotics with Burke and team. I also serve as the director of Sustainable Ventures at the Mercedes-Benz Global Fellowship Program on Sustainability and Climate Innovation. And we already have a number of climate robotics ventures in our program, and we'll be selecting 1,000 new fellows this fall. So here's more information in case you want to learn more. I'll post it in the Zoom chat. And now for a quick overview of day 3, we had 2 phenomenal speakers, keynote speakers, Professor Mirko Kovac and Professor Ali Niles, who gave talks on sustainability robotics and minimalist robotics, topics that are really close to our hearts here at the Climate Robotics Network. At the end of the day, if robots are not kind to both people and planet, then they're not really climate robots after all. The design principles that both keynotes actually spoke with and shared with us in their talks yesterday are really fully in line with our design principles for kind robotics. So if you want to have a look at that, that's also in the chat. That will echo a lot of the design principles that were shared by Mirko and Ali yesterday. Now, these design principles that I shared, they're very much community-driven principles. So this is really an open, continued open invitation to everyone to contribute to the further development and improvement of these guidelines for kind robotics. One hot take from the keynote session, there were a few, was that unstructured environments are not actually that unstructured. They're actually quite structured. It really depends in a way on ways of seeing, and that we should therefore use the notion that these environments are, after all, quite structured in interesting ways, use that as an enabler for non-intrusive, climate-friendly robotics. We then had 2 phenomenal panels, one on waste management and environmental monitoring. And I got to say, just over the past few days, I've loved hearing "I'm not a roboticist" from at least 1, if not 2 speakers that we've had in every panel during this summit, which means we're doing something right, because the whole point here is to have a multidisciplinary conversation and make sure that we get to learn from each other across disciplines. And by nature, climate robotics is a massively multidisciplinary field. And so the brilliant panels on waste management and environmental monitoring really then exemplified this multidisciplinarity beautifully. A few takeaways from the panels. E-waste disassembly is a sweet spot for robotics, and climate robots must not contribute to the growing disaster that is e-waste. Also, climate robots must be respectful and non-intrusive vis-a-vis ocean life, wildlife, natural ecosystems, and robots must follow the same life cycle as animals and natural ecosystems, ultimately returning to nature, for example, decomposing in nature upon the end of their lives. I thought that was a beautiful observation. And last but not least, community engagement, trust building, managing expectations when robotics platforms are being deployed or tested outside the lab, where they're meant to actually have positive impact. There needs to be an engagement with local communities, of course, and informed consent to build that trust and also to do no harm. All right, with that, I'm going to hand it over to my good colleague Marcello to moderate our first panel of the day on the topic of energy maintenance and inspection. Marcello, you have the mic.
Thank you very much, Patrick, and thank you for organizing all this beautiful event. We are just a co-organizer after your beautiful drive. And of course, thanks to the panelists of this very important and nice session on energy maintenance and inspection. I'm Marcello Calisti, your moderator for this session, and I'll do mostly timekeeping and just prompting the discussion with a few questions. So I would like to start this conversation with all of you, Sue, Jay, Nuno, Chang, and Hunter, with three brief questions, basically. One is why the climate challenge that you're tackling is important. What are you doing to do that? And how are you doing? Are you tackling this challenge? So, Sue first, and then I will move around.
Hi everyone, I'm Hunter. I'm part of the National Renewable Energy Lab in Golden, Colorado. So I do a lot of work with robotics for manufacturing and also how that impacts maintenance and inspection. My big focus is in wind, specifically wind blades, as those are very large, complex parts that require significant maintenance throughout their lifespan. I look forward to participating in this panel. Thank you, everyone.
Thank you very much, Hunter. Sue, so why the challenge you are tackling is important? What are you doing and how?
Yeah, so hello everyone, I'm Sue. I'm currently working at ANYbotics, a leading robot solution provider with major responsibility in managing our indirect sales channels as well as market development in APAC region. But in general, throughout my career, my focus topic is always service transformation in manufacturing industries and in the infrastructure areas, with special focus on what type of service and solution can help these companies to improve the production OEE. So maybe just a little bit about our company and solution and how it helps to address these challenges. I don't know if this is a topic we should talk now or we should first finish the quick self-intro round and then come back to this topic.
It's okay, let's say, to go on, maybe not too long, and then we move to the other speakers.
Okay, good. So basically, at ANYbotics, we aim to provide a fully integrated, industrial-graded autonomous robot, which can firstly be the co-workers of this, for example, power plant workers, and work in extreme weather conditions, remote isolated locations, or harsh environments, and basically to conduct routine inspections and ensure human can work in a safe and more comfortable environment. And additionally, of course, our solution also want to provide an out-of-box solutions for easy data collections with robots walking around and collect asset health data consistently and accurately. And therefore, we can help power companies to use this data to do preventive maintenance and reduce the potential downtime. So this is kind of what our company is focusing on and what I'm actually promoting and discussing today. Yeah, looking forward to the rest of the panel.
Thank you very much, Sue. Next, I will say, Jay, if you want to tell us why the challenge you're tackling is important, what are you doing and how?
Yep, Jay, nice to meet everybody here. So the problem we're focusing on is that, we're in this very unique point in time where the demand from decarbonization AI data centers have just required the world to scale energy infrastructure at rates we've never seen before, in the history of humanity. We are uniquely focused on the solar energy space, and what Luminous does is we build fleets of robots that help in the construction and the operation and maintenance of large-scale solar farms, both in the community solar space, which is like farms that are on the order of 10 megawatts or less, as well as utility scale solar, which is farms that are 100 megawatts plus.
Thank you very much, Jay. Nunos, you know the job, why the challenge you're tackling is important, what are you doing and now?
Hi everyone, so my name is Nuno Mateus and I'm the head of automation team in EDP R&D Center, part of the Portuguese utility here. And basically we are clients of these solutions. We are searching, we are making use of European funds to develop new projects, searching for technologies, building some partnerships with technology providers. And our idea is to find technologies, business models, and so on that can be then exploited for our business units. And the main reason behind it's of course around economics in order to speed and to scale everything that we are doing regarding the installation and deployment of renewables, both in a small scale, but also in utility scale. And at the same time, we are also dealing with some issues regarding the lack of specialized workers. So we also need to look for these autonomous and robotic solutions in order to overcome that kind of challenge. And I think that's it from my side.
You are muted, Marcello.
Oh, sorry about that. Thank you, Chang, and I was about to address you. So very timely intervention from your side. Why the task that they are doing is important for climate robotics. What are you doing here now?
Yeah, okay. First of all, thank you for having me, and thank you for the invitation, Marcello. So while I'm introducing myself, I'm allowed to share one slide, just a little bit advertisement for what I'm doing now?
We are doing without the slide, Chang. Sorry about that.
Okay. Anyway, yeah, it's okay. So I'm associate professor in robotics at the University of Southern Denmark. So so my what I'm mainly focusing on at the moment is to coordinate ongoing project funded by Innovation Fund Denmark. So what we're trying to do is that we're trying to use robotic teleoperation to facilitate wind turbine blade maintenance tasks, because nowadays we normally send human technicians to work at height. So they are called, I think, rope access technician, RATs, basically. So it's very dangerous work, costly, sometimes not possible because of the harsh weather. So our idea is trying to use a teleplay robot to take care of like some this basic maintenance tasks instead of like sending human technicians. And as you may know, that Denmark is planning to build a very large artificial energy island located in the North Sea, and it will be surrounded by a large number of offshore wind turbines. So we don't see it is possible to send human to take care of like this large number of offshore wind turbines as a sustainable solution. So as we believe that robotics can play an important role in this O&M, like inspection and maintenance of this wind industry infrastructure. So that's basically what we're doing now.
Chang, amazing. Thank you very much. I spent a few days in Chang Lab a few weeks ago, and it was great to see. So he has beautiful slides, but unfortunately there is no slide for everyone.
It's okay.
So.
Yeah.
Chang, thank you very much.
Some duty to like promote our project. Yeah.
Of course.
Okay.
And Ante, last but not least, why what you do? Why what you're doing is important? What you are doing and how? You already introduced yourself a little bit, but maybe you can add a few more words, and then we go on.
From my side?
No, Hunter. Sorry about that.
Yeah. So why what we're doing is important. So in where we work in the roboticists in our lab, we're trying to. Robotics is a long time and thought of a peripheral technology to the renewable energy industry. But we're trying to make the conversation revolve around more how it's a core enabling technology with the distributed nature of these systems and the labor shortages and the required supply chains for it. And so we're trying to really push robotics into this is actually a core technology to increase our development. And so specifically, I work in manufacturing. And so these large wind blades, 100 meters in length, as they grow longer, they're more prone to defects. And so being able to inspect and make sure you're getting a real quality, consistent part before it even goes into the field can offset a lot of those maintenance challenges that can happen even in the short term down the road. And so especially if you can make those maintenance schedules very consistent, you can better organize your workforce and the existing technology for those operations and maintenance, and overall reduce your levelized cost of energy.
Brilliant. Thank you very much. I'm super briefly introducing myself as well. I'm associate professor at the BioRobotics Institute, Scuola Superiore Sant'Anna, Pisa, Italy, and I worked mostly on underwater bio-inspired robotics for environmental inspection and restoration, and I also work quite extensively in agriculture robotics. So That leads me to the second question. We saw a beautiful different angles from all your companies or research labs about how we can deal with energy maintenance and inspection. My question for you is, sometimes the places are remote, and when I'm thinking of going underwater, there are so many different technical challenges. So in your point of view, what is the most difficult technical challenge that is not yet addressed for your specific domain? Let's start again from Sue, if it's fine.
Yeah, sure. I mean, in terms of technical challenge, of course, it has two aspects. One aspect is related to the environment, and another aspect is related to the technology. And for the environment, of course, we see a lot of difficult environment for robots to handle. For example, wind turbine is very good use case that, of course, to inspect the turbine, you need to send people in and then inspect it from inside, and to go into that turbine, it takes a lot of effort, and sometimes there are unstable situations, so the turbine might move and then a human gets stuck inside, and it's very dangerous. And of course, there are technology to address these certain situations, so that's more like from environment perspective, it's very challenging. And for our solution, probably the challenging environment we're looking at and also trying to help is, for example, remote locations, especially offshore wind substations. That's one of our big use case in the renewable energy area, because there are like remote, offshore wind farms is very hard to maintain. It's on the sea and sometimes it's far away. And also like there are offshore substations, and sometimes if you need inspection, you need to fly people over via helicopters, and that can be very costly and also very much environment unfriendly. And that's why our solution has a big focus on this area, hope to put the robot there, and so that they can do daily inspection and they can react when there is emergencies on the platform, so that you don't have to fly people over. So that's kind of some areas we're addressing, and this also include, for example, remote hydropower stations where they don't have people to inspect, or some areas where it has extreme weather conditions and therefore you want to avoid people to go in. And then from technical challenge, of course, for our robots, there are a lot of things. For example, for offshore substation, it's unstable, therefore it's always wave and kind of move with a wave, and how robots can maintain balance in such a platform is definitely a challenge. And also there are a lot of narrow corridors in some power plant like hydropower plants, and how to manage this type of terrains is another challenge for us.
Thank you very much. Mobility, the environment where we are working are extreme. Sometimes our renewable energy are in the most harsh and difficult environment on this planet. So it adds complexity upon complexity. Jay, what about the commissioning? Another big complexity is not only inspection, it is also manipulation in a sense, right? So what is your point of view on the most difficult challenge and the most technical limitation so far?
Yeah, I definitely agree there in terms of the environmental challenges. You know, these solar sites are in the middle of nowhere, they're fairly remote. And typically the topography is a big challenge as well. You know, being able to navigate through this type of topography. But I think more importantly, for the size of the solar fields, the scope is actually very, very challenging. You know, they're fairly large. The smallest sites are probably going to take you 30, 45 minutes to walk across end to end. And some of the largest sites could be, you know, 50, 60 miles across. And for folks not in the US, you know, that's like 100 kilometers. Like if you imagine a square, right? Like that's just astronomically large in terms of the footprint of some of these sites. So I think just the coverage and being able to like physically traverse some of these sites in a meaningful way and capture enough scope of inspection and maintenance is it's very challenging. You know, we also don't just inspect, we also manipulate these panels. So I think the large variety of different product brands is quite challenging to build a system that can, you know, physically manipulate all these sorts of different racking and different types of solar panels or solar modules in the space. Fortunately, you know, we've developed a fairly sophisticated technology stack to allow us to, you know, accommodate for all sorts of these variabilities, but it's still very challenging. And the overall industry is also evolving very quickly. So solar modules are increasing in wattage year over year, as well as increasing in mass and thickness of glass. So that's an interesting design constraint that seems to continuously move. So tackling that as it goes.
Great, Jay. It can be a mantra, no, for us that goes in the field, tackling this as it goes. So let's see what will happen, and then we try to handle the situation. And Nuno, beside the question about the most difficult technical challenge, you were talking also about lack of specialization of the workers. No, so you need specialized worker to do the job, but robots could potentially prevent that and help. And my two questions in this side are, first, of course, again, the technical challenge, but also, do we need specialization to use the robot as well? So can we give to people that have wind turbines or solar panels a robot and say, press a button, it will work on its own, or is more complex than that?
Yeah, replying directly, I think it's more complex than that. Coming back a little bit behind, I would say that for us and also do our scope, that is, we have a big range of activities right here, not only deploying renewables, large scale, but also small scale, and also managing in some of the countries where we are working, also managing the networks parts. So we have a wide range of activities and challenges, but I will try to resume. So we have the topic about the inspections on the asset side, but also on the grids. This is a huge task for us, and in some of the countries is also mandatory. So having autonomous solutions that can fly or run for several hours, checking what is going on, also trying to assess, for example, fire risk nearby our assets. It's a big thing for us, and we are really looking and trying to implement some pilots under that scope. When we talk about utility scale power plants, for example, like PVs and so on, I think the operation and maintenance, it's probably the huge challenge over here, because we have a massive space with the installed capacity that needs to be first assessed and then cleaned. And I think the actual solutions are not there yet. So and coming back also to your last question, for example, nowadays, even with what the market call autonomous solution, we need someone to guide these robots and so on. So I believe that we are far away from having completely autonomous cleaning systems for the diverse technologies. And then I would probably call a last topic that is really relevant for us. That is about security, the health of the workers and so on. We are managing with high voltage systems and so on. And if we have, for example, robots or something like that that can perform the most critical tasks by a worker, I think it's also beneficial for us. So it's not all about CapEx and OpEx, but also about security and health of the workers.
Yeah, totally agree. I mean, again, we are going back on the same topic. Difficult environments, they are very complex job, done sometimes in very dangerous conditions. Of course, the safest as possible, but you never know. A robot can help also on this safety side. Okay, good. Thank you, Nuno. Cheng, again, the most difficult technical challenge that you think needs to be addressed, and also, since we were discussing about, and I totally agree with Nuno, the full autonomy. In my experience, we try to pick a fruit, we try to manipulate valves. Full autonomy is still a dream, or at least I'm not good enough. Okay, let's put it in this way. In your case, that you have wind farms and hundreds of turbines, is it realistic that you have a teleoperation? How long will it take to teleoperate this 100 wind turbine? What solution can you see? So these two questions, technical challenge, and what do you think about teleoperation versus autonomy? Where are we going?
Yeah, thank you very much for the great question, Marcello. I think, yeah, so I think it's very common how to, let's say, balance the autonomy of the robots and also the involvement of the human operators in this inspection and maintenance of this wind farm or wind turbine. So what we're trying to do is that, okay, so so for the wind turbine maintenance tasks, the difficult part is that we cannot like achieve like 100% autonomy. Because I agree, like Patrick mentioned that like this environment is not like completely unstructured, but it's in something in between like structured and this completely unstructured environment. So for instance, like different blades, I mean, share similar like shape, but still, I mean, they would have different like damage situations. And also, for instance, that the curvature at the tip of like blade is quite different from like the other parts of a blade. So we do need like some kind of like adaptability of the robots. So at the moment, the company I'm working with, so they develop a robot which can automate, let's say 70%. The maintenance task of the wind turbine, but still for some part, for instance, the tip part of this blade, it's still very hard to completely automate the maintenance task. So what we're trying to do is that we try to use calibration to take care of the rest, to take care of the part which cannot be easily fully automated, and also in the future, I would say we still need to try to how to say involve the current AI techniques to improve the intelligence of the robot, to make our robot be able to adapt to the different situations. But still, I think it's a big question. How can we like involve different type of robots, and how to collaborate between this team of different robots and human. So basically, for instance, for now we use drone. We send drone for the inspection, which doesn't require any physical interaction with the blade, but the drone can tell, like for instance, this mobile manipulator, like where, I mean, it's heavily damaged. Then we send the robot. So it's like a robot can be deployed on the like wind turbine, and then we can calibrate the robot to actually perform this kind of like maintenance task, which does require physical interaction with the blade. So this is somehow like kind of like teamwork, right? Also like involve human operator and so on. So there is like a question how much human involvement we need in this kind of collaboration between humans and a group of different robots. Yeah. And yeah, I don't know. I mean, I think it's an open question. And also, even though there will be a huge labor shortage in this ONMN in wind industry, but still, I think if we increase this autonomy of the robot too much, then I think these human technicians might be afraid of losing jobs. Basically, that's also we probably need to take into account. Yeah. So I think there will be some discussion. Yeah.
Yes, it's also always a fine balance between societal need, but also labor of people and skills. What is happening if a robot could potentially do everything? Yes, totally agree. And thank you for your insights, Cheng. Last but not least, Ante, with the most difficult technical challenge for you, and as Cheng was mentioning, we have multi-team of robots that are going around. Sometimes we can find a spot where we can work instead of working on everything. So my question always here is, how long is not the autonomy in sense of behavior, but in sense of energy? So how long are our robots working, and how is realistic that they can last and do a job for the 8 hours shift that is traditionally intended? And then after you answer this question, we have few questions from the public, and I will direct the question to the appropriate panelist. So Ander, please.
Yeah, I think obviously, like, when you're performing these tests on a blade that's not actually, being flown up in the air, you can get a lot more lifespan or lot larger shift out of your system. Once you go up that tower, you start to just add a lot more challenges. And I say one of the biggest challenges for the maintenance and inspection industry on the inspection side is being able to, getting visual inspections is a lot simpler, if you're just using a camera. But once you start to need those subsurface inspections, it takes, it becomes a lot more complex process. Like if you're using ultrasound, that can require applying a gel to the surface. Or if you're using, infrared or other subsurface measurement techniques, it requires very precise movement of that scanner. So being able to design a system that can have that energy life to be able to perform a measurement on an entire 100-meter long wind blade, or being able to precisely position that scanner to capture that needed data while also being more efficient than actually sending a person up there is a big challenge on the inspection side. And then I think the maintenance side is that's a lot larger technical challenge. Like if you actually have to make a repair on the blade, that's in the soft fabric manipulation category, which is very computationally intensive, requires a lot of energy, and I think that's a lot further down the road in terms of actually a industry breakthrough for automation in that area.
Thank you very much for your insights, Hunt. Very thoughtful, very useful. We have 3 questions so far. One for Cheng, one for Nuno, and one for Jay. So we'll go the other way around this time. So starting from Cheng, and the question is, people are curious here to understand exactly, because they say, okay, the wind turbine goes in the soil, in the water, outside the water, and then there are the blades. So what do you think is the most crucial task that a robot can perform? And if you are taking care also of monitoring the biodiversity around the wind farm?
So in my current project, we're taking off like this wind turbines out of the water. I mean, the out of the water part of the turbine. So so basically that's the part that's spinning, right? So around this nacelle, I think. So I think, I mean, from what I heard from my company partner, I think most of the business actually come from like the blade maintenance at the moment. So that's the situation in the maintenance inspection and maintenance of wind turbine. So like blade maintenance, because I think after 1 or 2 years, I think one blade can easily get like eroded, damaged. So it needs like regular maintenance for each of the blades. So basically that's what we are currently focusing on. But and for the second one, I do think this monitoring of the biodiversity around the wind farm is very important. So how can we use robotics, for instance, to evaluate or maybe like to control like this biodiversity using, for instance, underwater robots? I think that's a very interesting topic. And also, I think in near future, we will also, so for instance, if we would like to build many wind farms like offshore, I think there is a trend that people try to use this floating foundations instead of like how to say directly connect this wind turbine to the sea floor, because that's very costly, right? So how to use robotics to, for instance, inspect and also maintain good working conditions of this floating foundations. I do think this is also a great opportunity for introducing robotics technology. For instance, maybe some, I don't know, maybe some mobile robots, some underwater mobile robots, something like that. I think that could be also very interesting. Yeah.
Thank you, Cheng. Yes, you're totally right. I mean, it's always challenging when you put renewables and you put elements in an environment that you don't know how it's going to be affected. Also monitoring the input that you are having is quite important. Or as someone was mentioning before, Sue, I think she said, if the wind turbine is so far that to go there with the helicopter, we are offsetting a lot of the benefit that we are getting is a fine balance. Okay, so yes, thank you very much. Nuno, we have a question for you, and then another one for Jay. And they are curious, and the public, what is the single biggest hurdle for EDP to adopt new robotic solutions?
So I can maybe explain a little bit about our process itself so you can better understand. So basically, we have our business units working in diverse types of technology, offshore, onshore winds, PV, utility scale, grids, and so on. So basically, they yearly identify some challenge that they are facing, or eventually they identify the areas that they would like to improve in terms of or CapEx or OpEx usage. And what we try to do is basically try to find solutions or try to build some partnerships to develop technologies or find technologies that can try to address these issues. Then we have two ways, or we work together with the company to develop the technology itself to address a specific topic, what will take too much time. And you can imagine, we manage when we go to the business unit and they are basically talking about money. It's hard to convince them that will take 2 or 3 years additionally to develop a technology. So usually this kind of situations only occur when they predict a need, for example, 5 years need, or about this issue that we already talked before about the shortage in terms of specialized workers. So we are predicting, we are already finding the solutions right now in our projects for 5 years. But then if we found out the technology, that the next step is trying to find a pilot in our assets, to build that pilot and check if in terms of efficiency and also the economics, the business model around it works. If it works, I think this technology will be adopted. What I can also share with you guys that the majority of the times in this kind of solutions, more autonomous robotics and so on, what we have seen is that the needs of the business in order to these solutions being really effective to reply to a real need, they are not there yet. So it's just a kickoff to solve a major problem the majority of the time, even when the TRLs are even higher and the solution already proves something. So to address specific needs of the business, we need every time to work with the technology providers to adapt the technology to the specific use case. So this is basically the way. But replying directly to the question, if the economics is there, if the performance of the solution work, we adopt it.
I see. So it's of course a discussion maybe to find the proper niche where to use the solution, and that gives me the right direction for the question for Jay, because people are curious to know what other sectors made your ground robots be an excellent fit for. So in which other application could you use your robots?
Yeah, I'm sure everybody has heard of humanoid robots. So, this is my past life back in like 2016. So the overarching mission for Luminous is actually we're building embodied robot solutions to tackle things that are beyond the scope of what humans can do, right? So turns out about 40% of manual tasks are just beyond the scope of incapacity of a single person. A good example of that is just like lifting solar modules. That typically takes 2 to 5 people to even lift that. So that being said, the solar and climate industries are very near and dear to our heart. We have been inbounded and requested for a number of other sectors as well. So things in like real estate construction and commercial construction are quite interesting for us. Picking up glass panels and types of plywood that look very similar to solar construction. Things like that we've been slowly investigating, but we're just laser focused initially right now in solar construction and getting these technologies to a point where they're adopted by our friends at EDP, for example.
Brilliant. Sounds yeah, a very nice follow-up for your work. Of course, I spent a few times also in knowing the decommissioning nuclear decommissioning industry, which also has a great, let's say, need for robots, and I think that this can be also another nice direction for that. So very good, thank you very much. And then I think that we are almost there, because we have a few more, 3 more minutes, let's say. And then let me do a final round with a very quick question of what's your hot take from this session and from your work, what you would like to transmit. It can be something that you are very passionate about, or something that it can be provocative for your sector. And in this case, we start again from Sue. What is your hot take from this?
Yeah, so basically we talk a lot about robots, but I think to some extent robot is like human, it can replace some human work, but at the end, the most important thing is about data. So we also very often see robot as a data acquisition tool, and therefore at the end, it's about how you collect the data, and there are always different tools to collect the data. So for example, for the wind farm, you have drones can inspect the wind farm from the top. You have underwater robot can inspect the underwater situations. You have ground robot can work on the ground platforms. So there's always different tools with different needs. And at the end, it's about what tools can collect what data and how you can utilize it. And that's kind of the most important questions we need to answer here beyond of the robot technology. Yeah, so that's kind of my take.
That's fantastic, Sue. Jay, your hot take?
My hot take, let's see. So I guess my hot take is we are not a technology company. You know, we don't go claim to do full autonomy. What we try to do is we solve problems. I think, you know, in solar in particular, you know, there has been a number of technology companies trying to do things for probably the past decade now. And I think one of the core reasons why technology is not being adopted is because there's this inherent disconnect between, you know, what the product is supposed to do versus what the value generation is for some of these companies. And not just value generation, it's like, how do you actually get people? You know, some of these people may not be of the highest education, right? And how do you get these folks to actually use this type of product, develop things in a user interface that makes sense for them? And then at the end of the day, how do you empower these folks to make their jobs easier? You know, we're all in together to try to scale energy infrastructure. And how do we build technology that actually gets adopted and used? I think that's our hot take, I guess.
Thank you very much. It's a very nice reflection. This increased adoption, and sometimes the mismatch between expectation and reality is painful. And sometimes I think that YouTube made more harm than good to robotics. But this is a topic for another discussion. Nuno, your hot take?
So I don't know if it's really a not take, but something that we are already facing that is related with robotic drones and so on to perform transportation and operation and maintenance for example, cleaning panels. And something that we have seen is that there are lots of limitations. I think the potential it's over there to optimize and to speed and to scale the number of installations that we need to perform, mainly in urban areas, or however, the regulation is not there yet. So I think it's the main constraint right here, because we have seen in several pilots that the efficiency, the economics, and everything is there. And in this case, the regulation is not following. So all the time that and this is my final message, it's basically all the time that we are thinking about technology, we need to follow it with the proper regulation in order to allow the technology to be well deployed and applied in whatever it's the use case.
Perfect. Thank you very much. And sometimes regulation appear out of the blue, and what was possible before is not possible anymore. Chang and Hante. Chang, very briefly, the hot take, and then Hante.
So probably I will say something more about from like educational perspective. I would say, I mean, like O&M in industry is still like very how to say, not very mutual from like this educational perspective, and also like scientific like perspective, because I think there are still some open scientific questions. So for instance, how can we do like shared control between human and a group of different robots, right? And how to, for instance, transfer our intelligence from through teleoperation to increase the autonomy and intelligence of the robot to automate like more tasks. I mean, this kind of thing. So I would encourage more students, young blood, to come into this area to actually apply robotics technology to this fantastic and exciting area. I think that's basically what I'm trying to say from like educator perspective.
Amazing. Yes, thank you very much. I totally agree. As professor role, we like also to educate, right? So, and Hunter, your is the last hot take, and then we leave the floor with just 2 minutes behind schedule. So sorry, Patrick, for that.
Yeah, so my hot take would be that I hear a lot about the concerns with automation and robotics impacting labor. And I think that, by increasing automation, you can really lower costs and improve the levelized cost of energy. And by improving those economics, you encourage investment in the industry, which encourages job growth, maybe in other areas of the industry. And in the long run, that actually create more jobs in the wind and renewable energy industry.
Amazing, thank you. So benefit can derive from different directions, even some direction that maybe we cannot expect, and eventually that you think are good, bad things that are happening, but indeed at the end of the day they are not. So thank all the speakers, very insightful, amazing talk, and now I leave the floor for the next panel. Thank you very much.